good afternoon to all of you, or good morning from maybe some of you. We are pleased with Carlos and Kelly to welcome you at this short webinar dedicated to thermal automation in food and beverage industry. Okay. So this webinar is proposed in collaboration with Alava Ingenieros. Alava Ingenieros is an automation R&D science premium partner, and Alava is based in Spain. My name is Antoine Bilardelo, and I am the South Europe team leader for automation and R&D science. With me today, Carlos Rosell Garcia, member of Alava Ingenieros organization. Carlos, could you please introduce yourself briefly, please?
Yes, of course. Thank you, Antoine. First of all, thank you all of you to be with us today. My name is Carlos. Inside, I am from Alava Ingenieros, and I am inside of the thermographic department, and I am the product manager for automation and science. So please, your turn, Antoine.
So in the background, Miss Kelly Austin will be with us. It's our automation R&D science marketing leader. Kelly will be our webinar maestro today. Anyway, we will start. Note, we will have a questions and answers session at the end of this webinar. So prepare yourself. If you have any question, we will be pleased to answer to them. Carlos, could you please introduce briefly Alava Ingenieros?
Yes, of course. Well, Grupo Alava or Alava Ingenieros is a Spanish company, and we have more than 50 years of experience on the high technology sector. Our philosophy is to help our customer in search the best solution to solve the problem that they propose us, offering a high add value solution to improve their process and reduce their cost. So we can talk that Alava has some different companies. The matrix is Alava Ingenieros, but we can talk about MRA, that are our delegation in Portugal. Preditec, that it's specialized in predictive in predictive maintenance. Alava Internacional and Trosadia, that work together, and they are more focused in civil engineering. And the last part of the company is Monon, that is dedicated to solution of big data, industry 4.0, EOT, so all the digital world. Please, Antoine, can you continue?
Yes.
Please?
Thank you. So Teledyme Flir, briefly, Teledyme Flir is member of the Teledyme organization now. Years ago, we were 100% thermal cameras oriented. We are today 59%. Anyway, we continue to offer the hugest portfolio of thermal cameras on the market. All our industrial fixed mount thermal cameras have a name stating by A. For your information, in A means automation. So for the automation online applications, we offer two families of thermal cameras. Smart cameras with alarms on boards and streaming cameras. The streaming cameras are all Genicam Gig Vision for an easy integration on third-party software. We offer a huge selection of cameras based on different KPIs to fit best as possible the applications of our customers. Recently, we introduced InSpec software for customers who want to develop by themselves some custom application. The goal of InSpect is not to replace a dedicated custom software design solution. It's not enough powerful to do so. The aim is to fulfill basic requirements or to perform an easy prototyping. Easy. Make it easy. That's the purpose of our engineers when they have developed those cameras. Smart cameras propose alarms, electrical alarms, as well as alarms through internet. As you can see, we offer solutions for high-tech environment, indoor, as well as outdoors. Here also, our engineers have developed those cameras having in mind no stress for the customer and the system integrator. The installation and use must be easy and friendly. Unique selling point. For more than 60 years now, we are developing and manufacturing thermal radiometric cameras. So we have a beyond compare expertise there. Trust me. Trust me. Our cameras offer unique selling points, and we will be pleased to introduce you in regard of your applications. That said, now it's time to cover some example application. Carlos, the stage is yours.
Thank you, Anton. Well, in this part of the point of the presentation, I want to split or to divide in two parts. First of all, we are going to talk about different techniques that we use in the world of food. And in the other blog, on the second blog, I would like to talk about real project that we have developed with software and solution, sometimes made in Alaba, other times with helping our expert or integration or collaborators. Okay, the first slides that we see is temperature control. Okay, it must be taken in account that in the food industry, temperature control is one of the essentials to ensure that the food comes to our homes, to our supermarkets in a perfect conditions. For these temperatures during the process of preparation of these foods is fundamentals. Okay, as you say in this slide, the goals for us is has a good quality of control of different temperature. The solution that we can offer is using thermal cameras with software or smart cameras to normally look for minimum and maximum temperatures, detect hot and cold spots, and detect different sound with that can cause different errors. In this case, we can talk about the advantage to use a Flir or Teledyme Flir's camera. The first thing that I want to say is that it's easy to integrate these cameras with the other devices in the factories. Other thing that I want to say is the accurate. We need strong cameras and accurate cameras to always has the same control points. Okay, and the last one is has a recognized brands. It's it's so nice to work with Flir in this kind of application because they has an excellent technical service and an excellent support. So when you have a problem, this is a you need a good support. Anyway, please, Antoine, can you go to the next slide? Talking about other tests that we can do is the quality for filling or counting control. As you see in the video, this is a real proof of concept to test the technology. We use a Flir, an A400 Smart, and what we see is how full the bags or containers are. So here are, well, it's a test on a real company. The goals at the end is to have a quantity or quality control of the fill, okay, of the containers. The solution in this case that we offers, I mean, is to try to see inside the containers. I mean, it's not that's not that we don't have X-ray in the camera. By using thermographic, we can see how the surface of the container is heating or is cold. So we can see inside. That's I see that we can see inside. I mean, in this case, the the most important things that we can try to find in a camera to help our customers, first of all, is the quality of the imaging. Okay, you need a high imaging quality, you need a good sensor, and of course that sensor has to be a high sensitivity to see this kind of effects. Another feature to take account is to have a good frame rate, because sometimes you need a good frame rate to have the maximum quality in the captures, because you don't need blur in this capture. And in this case, this is all that we find to help our customer. Please, Antoine, next. Well, this is other of our products. In this case is selling control. This is a proof of concept and a video presentation that we made for one of software made in Alaba. This technique in many cases require a special software and hardware development, and they are not easy to implement, because it's not be taken in account that there must be a thermal contrast to be able to see this kind of failures. Okay, the solution that we proposed to our customer was Ignite. It was a software made here in Alaba for our engineers. As you see, the solution, we try to see to solve, to detect some problems during this during the process. Okay. First of all, we try to see bed inspection for any body, meat, food, anyway, in the ceiling, and error on the ceiling like bubbles on sealed area. Okay. In this case, we can talk about the technical complexity to be able to see these defects. It's sometimes necessary to have external heat sources. Anyway, if we talk about cameras, the first thing that we can see or that we can have is the high thermal stability, because sometimes this kind of products are in extreme condition, like hot or cold condition. Okay. Another fundamental factor is to have a large new number of lenses available, because sometimes the position of the camera is the main problem that you can or you have to solve. So in this technique, it's necessary to take advantage of every pixel in the imaging. And finally, the synchronization, okay? Because sometimes you only have some milliseconds to take your photo. So in this case, your camera has to talk with protocols to communicate when the camera has to do these photos. Talk with PLCs, okay, talk with other cameras or with other device that giving the signal for capture. Okay, please, Antoine, the next one. And other kind of test that we can do is the quality control of food, of vegetables, okay, of meat, anyway, food at the end. As we know, or well, in other band on the electromagnetic spectrum, we can see how the fruit, the vegetable, or the meat has another properties. If we look this part of the spectrum, we can see different effects. I mean, at the end, the goals for this quality control is to take in advance of change of emissivity or temperature to see this change in the organoleptic properties of the food. Okay. The solution with this temperature change detection or change of the values in the other infrared bands, we try to detect this kind of defects. Okay, mechanical damage or damage. Well, my English so is not good, but anyway, contamination, repairing, or human error. Okay. It's important to have cameras that are able to use filter, because with this filter we can detect exactly the defects bands, okay, and see what is happening in this fruit, vegetable, food anyway. For example, the imagine that you can see is an apple that has a defect. I think that is a hit or something like this, and you can't see this defect on the visible spectrum. So we can go to the other part of the electromagnetic spectrum to see this defect. Okay, at the end. The resolution is very important in this kind of quality control, because these defects sometimes are very small. So this is one of the advantages of the values that you can try to find. Okay, this is all that I has for the techniques. Okay, so please, Antoine, can you go for the next one? Well, now we go to the real life, and we are going to talk about the real project. Okay, the first project that I want to show you, and this project for me is special because it was the first project with thermographic camera that I have to do. In this case, is the FRIAS. FRIAS is the Fruit Imaging Analysis System. In this case, this customer is a European leader in organic fruit and vegetable. So to increase the quality in their process, in their production chain, they trust in us for do this application. As you see in the slides, okay, there was only a customized software and hardware to do a control temperature. The goal at the end of was that the food arrived to our store with optimal, with the best characteristics. So what we did in this case, we use some Flir A35 to control the temperature of the entrance in other points, in other location in this factory. So they take the data, the temperature data of the food, and then with some algorithms, they plan a strategy to send the fruit, the vegetables to different cold room. Okay. With this, they guarantee a perfect degree and quality of the food to export to other countries. So we use It's like I say a Flir A35. And for do the software, we use Matrox libraries, okay, and a Matrox industrial computer. Why Flir? Why Teledyme Flir? First, because it was so easy to integrate the cameras with Matrox libraries. We have been working with Matrox for several years, and the integration was super easy. Other thing was the size of the camera, okay? Because you can think that in a factory like this, you have a lot of space to place the camera, but really is not that true. So sometimes you have a problem with the space and where do you place the camera. And of course, in this case of an application, you need a calibrate camera with a good accuracy. So this is one of the first project. So please, Antoine, can you go to the next one? Well, Ignite project is based on it's a solution created here in Alaba. That's apply different algorithms of artificial vision and deep learning to detect problems in the food packaging. Okay, normally the problem that the customer try to solve is that normally these containers, these bags, are vacuum packets. So if we lost this vacuum, can has a problem in the food when arrives in a bad condition to the supermarket. I mean, you lose there's comes inside the wagon, and you can have problem with the food. Okay. At the end, the goals of this project was detection some failures in the sealing of different plastic containers. Okay. In this case, they has problem in some sealing because the customer lost this vacuum. Okay. What was the solution that we offer to the customer? Well, we create a thermal analysis system, as I say, with deep learning and machine vision libraries, trying to find the foreign bodies in the middle of the ceiling, meat, food, whatever in the ceiling, and errors caused by the machine, by the sealer machine. Okay, normally are bubbles and unsealed areas. Okay, I should told you that this technique is not easy to apply. Okay, because you sometimes you need to have a thermal contrast that you have to add some heaters to make this different between the to show the defects of that comes the defects to see the defects. I mean, what we use for this project? Okay, we use Flir A65 normal industrial computer, and we did the software with the Matrox library. In this case, we use Flir because over time, Jenica and Vision is fully compatible. So in this case, it's easy to integrate with other third party and with other devices. Okay. Other the advantage that we find is we need the maximum resolution to try to have the best detection, and we need to a good wide combination, a good wide angle combination with lens and camera. Okay, and of course a calibrated camera because some of the defects are based in temperature problems. So please, Antoine. Well, this is one of our last projects. It's a DIMAR project. In this case, DIMAR is an engineering company located in Asturias. It's north of Spain, and they has a well, they has a specialized in creation of solution for the industry. Normally using artificial vision cameras. Okay. Dimar, in one of the last project, in this case, we help Dimar to find the better solution, to the better hardware to solve the problem that they have. Okay, at the end, they have a problem because they want to see inside the bags, okay, to detect and to recognize the food that was inside the bags, okay. They need to control the quantity, the shape, and it was doing by with the Flir A68 because they have the products that comes are froze, okay. It has a cold products. The problem that they have is that this kind of bag are opaque, and as they come from the supplier. As you see in the video, they have created a machines by artificial vision. They were able to know if the products meet the quantity, the shape. So at the end, they have a quality control of their products. Okay, in this case, we use the new Flir A68. Okay, they use an industrial computer, and for the communication to do the software, they use Spinnaker. Okay, the SDK for this kind of camera. Why use Flir in this application? Okay, first of all, because the news camera for the A68 are very small, very small. So in this case, they has a problem with space. Okay. Other thing that we talked about was that this machine are going to be in a extreme condition. Okay, maybe minus 10 degrees, something like this. And we find a camera that they can use in this extreme condition. Another thing is the cost, okay? Because at the end, the final machine has to need to be competitive as possible in terms of economic cost, okay? So this is the why we use Flir. And the last one, but not the least, please, Antoine. Well, in this case, countdown detection is another technique that we talk about it. I can't tell you much about the customer, but I can tell you that this proof of concept was for one of the large food company of fast food. So this company has an idea of adding fried eggs to one of their sandwiches. And a Spanish company made a method where by controlling the temperature of the eggs, because that you see in the imagine on the video are fried eggs, okay? They control the temperature of the white part of the eggs and the yolk of the eggs, and then they could ultra freeze the egg. What was the point? Because when they do the opposite, I mean the frosting, the eggs are in perfect condition. So in this case, the temperature was the key. They need a very accurate in the temperature. Okay. Apart of this temperature control, they need to control the proportions of the eggs. I mean, like we say in Spanish or in Spain, sometimes we eat by what we see. So if we see a nice meal, we say, "Oh, this would be the best," but it's not are very very beautiful. Okay, you can say, "Okay, this is not my meal." I mean, for this concept, for this proof of concept, we use a Flir A655. For me, it's one of the best thermal cameras in the Flir catalog. Okay, with this camera, we have a perfect definition on the edge of the X. I mean, we can see perfect the edge. We have to do windowing. We have to use the windowing mode because the speed of the production line was very high. So we need to increase the frames per second to have a perfect photo, okay, a perfect thermographic image. And last, we use this camera because sometimes they tested different type of containers. And these containers where the eggs were cooked, okay, change when they change the containers. Sometimes it was necessary to modify the focus plane. So this camera has motor focus, okay, has autofocus. So this was an advantage for us. Please, Antoine. Yeah, for last, and not for least, I would like to finish my presentation, or I don't like to finish my presentation without telling that Grupo Álava this year is our 50th anniversary. We would like to celebrate it with you. Please, Antoine, can you pass to the next slide? And I say it's our birthday. We are in the last 50 years of history in technological market. We are going to celebrate it in an event called Overfly. Okay, this is a professional networking event where you can discover advanced technology projects, share ideas with other professionals of the sector. More than 100 people will join us to our flight forum, and maybe of them decision makers. Overfly is a place for present and the future of the industry. And if you are in Madrid, in Spain, the next 21 of 22 of Jan, please, you are invited. So you are invited to come with us and to take a nice place to talk about technology, to talk about ideas, to talk about uh, industry, science. So thank you very much for that's my my part. Thank you very much for your attention, and please, Antoine, can you continue with the presentation?
Thank you, Carlos. Thank you, Carlos.